Hello there. Today we're going to derive the cosine difference formula. I am Cecilia Baez and I will be your professor for the time period. To start, the cosine difference formula is cosine beta minus alpha equals cosine beta cosine alpha plus sine beta sine alpha. And how we're going to find the origin of where this came from, we'll start with the unit circle. Obviously, this is pre-calc, trigonometry. The unit circle plays a very important factor. It is the base of everything. So the unit circle, its coordinates of the unit circle always branch out to 1. The pinpoints, as you see, are 1, 0 for the first dot, and the second dot at the top on the y-axis is 0, 1. So we have a triangle here, and the triangle has points A and B. Where A and B meet, you can call that point C, but we're not going to name that. Anywhere from the center of the circle to perimeter of the unit circle has a radius of 1. Now, angle A is alpha, angle B is beta. Angle A has the coordinates of cosine alpha, sine alpha, and angle B has the coordinates of cosine beta, sine beta. Now that dashed line can be the length of AB, which also leads to the angle of beta minus alpha, which we're going to try to find the angle of beta minus alpha within this. To start, there's a few things that you should know. Law of cosine should definitely be a strong background, the distance formula, how to use it, and the Pythagorean theorem identities. So going to law of cosines, we could start with a smaller version or a bigger version of the triangle and unit circle, which you have angle A, angle B, you have angle C. And the opposite of the angle would be a triangle leg, which can be the mini C, mini A, and mini B. To find the length of AB, which we'll start with finding the length of AB, would be the same thing as finding the length of C. Now, one of the law of cosine equations to find the length of C is C squared equals A squared plus B squared minus 2AB to the cosine of angle C. Now, you can basically substitute that same exact thing for AB squared, because it's the same thing as C squared, AB squared, just finding the length. AB squared equals A squared plus B squared minus 2AB to the cosine. Now angle C is beta minus alpha, cosine of beta minus alpha. Starting with the equation, A would be one of the legs of the triangles, which is a radius of 1, or length of 1, because it is the radius of the circle. A squared is 1. And B would be the same exact thing, 1. So you have now AB squared equals 1 plus 1 minus 2 to the 2 cosine beta minus alpha. Combine like terms, you have AB squared equals 2 minus 2 cosine beta minus alpha. That's how you find the length of AB using law of cosines. Now we're going to try to find the same exact thing, or try to find the length of AB using the distance formula. The distance formula is D equals the square root of x2 minus x1 squared plus y2 minus y1 squared. Now you have your two sets of coordinates A and B. A is cosine alpha, sine alpha. B, cosine beta, sine beta. You can mark up how you want it. You can either have either or x1, x2, or y1, y2, just be consistent with it. If you plug everything into the formula, you have D equals the square root of cosine beta minus cosine alpha squared plus sine beta minus sine alpha squared. To reverse the square root, just say D squared equals cosine beta minus cosine alpha squared plus sine beta minus sine alpha squared. Now D squared, the distance between A and B, would be the same exact thing as the distance between A and B squared. Like, it's the same, D squared equals AB squared. So you have AB squared. Now what we're going to do is we're going to FOIL everything out and expand the equation. Now you have AB squared equals cosine squared beta minus 2 cosine beta cosine alpha plus cosine squared alpha plus cosine squared beta minus 2 sine beta sine alpha plus sine squared alpha. Very long, very breathtaking. Now, this might be a lot. Pretty cool stuff happens when you really look deeper into what the equation might hold. If you use the Pythagorean theorem identities, cosine squared theta plus sine squared theta equals 1. So how can we combine this with the equation that we're given? Well, cosine squared beta plus sine squared beta would equal 1. And you see that again, cosine squared alpha plus sine squared alpha would equal 1. So you have that there. You can also factor out the two negative 2's along with the cosine beta cosine alpha sine beta sine alpha, which leaves you with 1 plus 1 minus 2 to the cosine beta cosine alpha plus sine beta sine alpha. Combine like terms, and now you have AB squared equals 2 minus 2 cosine beta cosine alpha plus sine beta sine alpha. Now, you solve for AB squared through the law of cosines, and you solve through AB squared through the distance formula. Well, AB squared will always equal AB squared, so it means both equations are equal to each other. So set them equal to each other. So you have 2 minus 2 cosine beta minus alpha equals 2 minus 2 cosine beta cosine alpha plus sine beta sine alpha. What you can do from here now is you can subtract both constants, negative 2 each, and then divide by both the negative 2's that are being multiplied, which once you divide and subtract, you are left with cosine beta minus alpha equals cosine beta cosine alpha plus sine beta sine alpha, which is the difference formula for cosines. Thank you.